So that's a quick question on normal distribution. You can see here on the right hand side of your screen. So we have that the heights h of the people in a certain town are normally distributed with mean of 170 centimeters and a standard deviation of 20 centimeters. For the part A, we want to find a person is selected randomly, and we want to find the probability that the height is less than 185 centimeters. What it actually helps, regardless whether you've been asked by the question to do it or not, is to draw a little graph to kind of show of the area of the normal curve that you are actually calculating. So that's a pretty kind of good normal curve, and we want the mean to be 170, and then we have that the standard deviation is equal to 20 centimeters, so that's okay. For the first part, the question is asking us to find the probability that a random selected person has a height more than 185. So if I choose to put 185, which is less than one standard deviation away from the mean or above the mean, then essentially what I'm asked to calculate is the highlighted green area that you can see now on your screen. Now the way to do that is by going on the calculator, and after pressing menu we go into probability and then to distributions, and we want number 2, the probability CDF. That's the cumulative probability from for the normal distribution question that we're doing. Now the lower bound, we want it to be as low as possible. The calculator by default has the minus 9 times 10 to the power of 999, which is a really, really small number. But even if you change that to minus 100,000 or 10,000, that will not change your result. The upper bound, I want it to be the 185. Then the mean and the standard deviation are given with 170 and 20, and then once you press OK, that should give you your answer, which is 0.73, which can be approximated to 0.773 to 3 significant figures, or otherwise to 77.3% if we want to make it a percentage. Now if we want to work for the part B, what we need to do that, I'm going to do the same thing. I'm just going to draw the shape for the part B to show that what part of the what proportion of the normal curve area I'm calculating. So it says here that there is a probability of h of the height to be bigger than d, such as the area to be 0.6808. So let me put the mean here in the middle again, and I want the area bigger than that number d to be around 68.8%. So let me choose a d which is on the left half, because I know that this is the 50%, correct? So if I want it to be like bigger than the 50% and around 68.08%, not around exactly, then I might as well just put the d on the left hand side, right? And that's the information that I have, that the area here is 0.6808. Don't forget the area under the curve, it sums up to 1, right? Because this represents all the possible probabilities. So essentially, what it would make sense is to calculate, let's highlight it with a green again, the area on the left, and to find that area on the left, that's going to be 1 minus 0.6808, which will result into, let's use the calculator for that, 1 minus 0.6808, and that will give us 0.3192. 0.3192. Now, for that kind of question, because I've been given the area and I'm trying to find the D, I will have to use the inverse normal distribution. And the reason that I found to calculate the area, because the inverse normal distribution calculates from the left to a specific point. I was given that D, the probability bigger than D is 0.6808. Therefore, I did 1 minus 0.6808 to find what would be the remaining, the green area. And now we'll use the inverse normal distribution. So back into probability, number 5, and then inverse normal. And then I'm calculating using the green area, because again, the normal distribution would start from the left, scanning the distribution and just calculating up to a point D. And this is what you always need to do. So let's go and do that. My area is going to be 0.3192. The mean remains the same, 170. The standard deviation remains the same, which is 20. Press OK. That would provide you with that value here. So the D is going to be equal to 160.601, and approximated to 3 significant figures is going to become 161 centimeters to 3 significant figures. Now, what would also be helpful is if you write at the front what you have exactly on the calculator. So that would be some sort of evidence of the work you did. So I'm going to write inverse normal and then 0.3192, 170, 20. And that will show clearly what I did in order to calculate that 161 centimeters.